In this video, you will learn about what are organic compounds and homologous series, the classification of organic compounds, features of homologous series, and the IUPAC nomenclature of alkanes, alkenes, and alkynes. Organic chemistry is the study of compounds that are mainly made up of carbon. Carbon has some unique properties that allow it to bond in diverse ways and make millions of organic compounds. All living things consist of many different organic molecules. Carbon is able to form such a diverse range of compounds because carbon is tetravalent, that is, it forms 4 covalent bonds. Carbon can also form strong bonds with other atoms, such as with hydrogen, and the CH bond is quite strong and it can form long chains of carbon and hydrogen molecules. Carbon can also catenate, that is, it can self-link. It forms long chains of strong C single bond C or double bond between two carbons or even triple bond. It is estimated that there are more than 10 million organic compounds, and the study of these compounds have to be in an organized way. Therefore, the compounds are classified into groups called homologous series. A set of rules are prescribed by IUPAC to name the members of the homologous series. Before we learn how to name them, here are some features. Members of the same homologous series have the same general formula. The difference in the molecular formula between one member and the next is 1 carbon and 2 hydrogen. They have similar chemical properties, but there is a gradation in their physical properties, such as their melting point and their boiling points. Before we discuss the IUPAC nomenclature of homologous series, let us have a look at a broader classification of organic compounds. This is a simplified version which is enough for HSC studies. Organic compounds are broadly classified into aliphatic or open chain compounds, or cyclic, that is, closed chain compounds. Aliphatic compounds are further classified into straight chain and branch chain. The cyclic compounds are further classified into alicyclic and aromatic. Alicyclic compounds are closed ring structures made of carbon, and the aromatic have at least one aromatic ring, for example, benzene. We'll discuss about cyclic compounds in later video and workbook. In this video, you will learn about the naming of the simplest aliphatic compounds called hydrocarbons, which are alkanes, alkenes, and alkynes, and they are made of only carbon and hydrogen, and we'll discuss the straight chain hydrocarbons. Let us understand how to name straight chain hydrocarbons. As mentioned earlier, carbon can catenate, that is self-link, and form long chains. To name the hydrocarbons, all straight chain compounds have a primary name referred to as alk. It's a prefix in the name. For example, alkane, alkene, and alkyne. The prefix alk refers to the number of carbon atoms in the chain. Alk is accompanied by a suffix. If the suffix is ane, it indicates that there are only single bonds between the carbons in the entire chain, irrespective of its length. The suffix ene indicates that there is at least one double bond in the carbon chain, that is a CC double bond, and ine indicates there is at least one CC triple bond in the carbon chain. So here are the names of the first 8 members of alkanes. The general formula of alkanes is CnH2n plus 2, where n is the number of carbon atoms in the chain. depending on the number of carbon atoms in the chain, the alk is given a specific name. You'll have to rote learn these names. For example, you have methane, ethane for 2 carbon, propane for 3 carbons, butane for 4 carbons, then pentane, hexane, heptane, and octane. These compounds can have many carbon atoms in the chain, so there's several ways to write the formula of the compound. So first is the molecular formula, which follows the general formula CnH2n plus 2. So the molecular formula of the first 5 alkanes is given, and it can also be represented as structural formula. In the structural formula, all the bonds are shown. Note, when adding hydrogen to the carbon, carbon should form 4 bonds in total, not 3 nor 5, only 4. And here's the structural formula of the first 5 alkanes. So that's for propane, butane, and pentane, which has 5 carbons. Another way of representing is the condensed structural formula. It is similar to the structural formula, but does not show all the bonds. And this is how we write the condensed structural formula of the first 5 alkanes. You might want to practice writing the formula of hexane, heptane, and octane. Another way of representing is the line formula. For example, hexane, that is C6H14, there are 6 carbons in the chain, and the line formula would look like this, where each corner represents a carbon with appropriate number of hydrogens, and you can see that there are 6 corners there, while for heptane there would be 7 corners, and this would be the line formula for octane. The rules for naming straight chain alkenes and alkynes are similar to alkanes in that the prefix alk represents the number of carbon atoms in the chain. However, the suffix changes to -ine or -ine. So here's how we name straight chain alkenes. The general formula of alkenes is CnH2n, where n is the number of carbon atoms. The first member of alkene series is ethene, and here's the molecular, structural, and condensed structural formula. And the next member is propene. And then there is butene, which is a 4-carbon alkene. In butene, there are 2 possibilities. You can see that both the compounds are butene, but the position of the double bond in the chains is different. In naming these compounds, the position of the double bond has to be stated. For that, we number the carbon atoms either from left to right or from right to left. The correct numbering would be the one where the lowest number is given to the position of the double bond. Here, you can see that in the numbering from left to right, the double bond is between carbon 1 and 2. In numbering from right to left, the position of the double bond is between carbons 3 and 4. Therefore, the first numbering would be correct, that is between carbons 1 and 2. And so to name it, we first write that this compound is a butene because it's a 4-carbon alkene. And then we put a 1 with a hyphen in front, indicating that the double bond is between carbons 1 and 2. Note that in IUPAC nomenclature, there's always a hyphen between a number and a letter. To name the second compound, we write butene because it's a 4-carbon alkene. Then number the carbon atoms from left to right and from right to left. You can see either way the double bond is between carbons 2 and 3. So we choose the lower number 2 and write it in front of butene with a hyphen in front. So the two possibilities with butene is 1 butene and 2 butene. The numbers 1 and 2 indicate the position of the double bond in the carbon chain. Here are two more examples. To name this compound, we know it's an alkene because it has a double bond. Then number the carbon atoms from left to right and from right to left. And you can see that it has 8 carbons in the longest chain, and therefore the compound is an octene. Then assign the lowest possible number to the position of the double bond. From left to right, it's in position 5 and 6, and from right to left, it's in positions 3 and 4. So we choose the lower number 3 and place it in front of octene. So this compound is 3-octene. This compound is a 6-carbon hexene, and therefore we write it as 3-hexene because the double bond either way is between carbons 3 and 4. Rules for naming of alkynes is the same as alkene, except that the name ends with an "-ine". The general formula is CnH2n-2. This compound is 2-pentyne, and this compound is a 4-carbon alkyne, so it is 1-butyne. So in the workbook, you'll get to practice questions on naming straight chain hydrocarbons. So good luck and enjoy.